What is up, stats nerds? So we are going to run some logistic regression today in SPSS. And so we're using the general social survey data. And what I'll do is I'll talk about the data briefly, and then we'll run our analyses, and I'll talk about the variables. So the general social survey is a survey of opinions from the general public in the United States. This is the 2018 data. That's the newest data for SPSS. And so here I'm interested, let's say I'm interested in the probability of somebody voting for Donald Trump for 2016 president based on a variety of factors, right? So we'll look at a couple of demographics, we'll look at political views, things like that. And so this is the data set here. This is a really extensive data set. I'll talk about those couple of variables real quick. So one of the variables, political views, not political views, but President 2016. It's actually a recode where Clinton equals 0, Trump equals 1. And that's a recode from PRES 16, which I'll run up here real quick. President 16. That's not a recode. That's a typo. I accidentally did that. And so I recoded it because we have these other pieces in here. Didn't vote for president. Other specify IAP. So I just took those out. So we'll only be analyzing people who voted for Trump or Clinton. All right, and then we have some other variables in here that I'm interested in as well. So we'll just jump into those and see what we got here. So the way we start with logistic regression is we want to go to analyze. We want to go to regression. And so remember, regression is a logistic regression is binary, meaning the dependent variable has two categories. So it's a categorical binary variable. Right. So in this case, we're looking at essentially the probability of somebody voting for Clinton or Trump. Right. So we're going to go binary logistic. And so our dependent variable is going to be President 16 recoded. All right. Then I'm interested. I'll use this INSTCON. That's another variable we created. It's a continuous variable that looks at the extent to which somebody is trusting of institutions, of U.S. institutions. We'll use our political views, and so that's a recoded variable of Paul views, which is this one codes liberal, moderate, and conservative. Then we'll go up to the top here, and I'm also interested in age, so we're going to add age. I'm also interested in attend. So attend here, this variable is how many services, how many church services or religious services somebody attends a week. I believe it's a week. It might be a past month. And then the last one I'm interested in is Con Inc., and that is somebody's income, their income for the past year. All right. So we're going to start off there, right? The next piece we want to do is we want to go to categorical. So we want to click this categorical tab. And we're going to put Paul views in the categorical covariates. Even though attend is classified as a categorical variable, we're going to leave that as a continuous variable because it's an ordinal variable, but it's sort of like a continuous ordinal variable. So we're going to keep that as essentially measured as a continuous type of variable, right? So the only one we're putting over in categorical covariates is the political views. And we're going to set this reference category as first, all right? So we know that's, or I know, and you would know this if you ran descriptives on this, or frequencies, I should say, that 1, it represents liberal, 2 is moderate, 3 is conservative for this recoded variable. And so we're going to keep first as the reference category, right? So if you remember in regression or logistic regression, if you have a categorical independent variable, essentially what it does is it breaks that variable up into essentially multiple dummy variables and contrasts it or compares it with a reference category. All right. And so we're going to keep liberal as the reference category. So we're going to click continue here. These are some other things that aren't necessarily of interest. So we're just going to leave these as is. We don't need style or anything like that. So I'm just going to leave it. And we can, I like to click paste because that puts it in the syntax, and then I can manipulate it later if I want, but I'm just going to click OK here. All right, so let's look at our logistic regression. So we're going to go line by line here. So here's the first line. So this tells us we ran a logistic regression. This tells us our number of cases in the analysis, right? So we included 816 total cases. There's 1,500 missing cases, 1,532 missing cases. We have our dependent coding. So 0 is Clinton, 1 is Trump, right? We can see that. And then we have our categorical variables and the coded there. So liberal, moderate, conservative, right? And then we have our beginning block. So this block you actually kind of want to ignore. So this is essentially a null block, meaning it is a block that includes 0 predictors, right? So it's an analysis that includes 0 independent variables. So it's just the dependent variable. So we want to kind of skip over that. And this tells us sort of similar information, right? So there's nothing in there except the constant. And then it tells us the variables not in the equation, which is all the variables that are in our second block, right? So now let's jump down to our second block. The omnibus tests of model coefficients tells us whether or not the full model is significant, right? And what you can do in logistic regression is if you're interested in testing different, we call them blocks, what you can do is, let's say you're interested in controlling for the demographic variables. So you might enter the demographic variables first and then run that analysis. Then in the next block, you would add, let's say, an independent variable or a couple of independent variables that you're interested in seeing the actual effects of those. Then you would add to those, right? And so you can sort of go down the list there. And what that does is it lets you identify basically the extent to which a different sort of blocks of variables account for different variation or different percent variation in the dependent variable. So we just did one here, so it's simple, right? But we can do multiple blocks. This model summary here tells us essentially the percent variance accounted for. So this Nagelkirk R squared is a good sort of indicator of our percentage accounted for. And what this is telling us is that from the variables that we used, 47.4% of the overall variance in the dependent variable of voting for Trump or Clinton was accounted for by our independent variables, right? So what that means is on the flip side of that is there's, roughly 53% of the variation that isn't accounted for. So there's 53% of other stuff that is in there somewhere. This classification table tells us the predicted values versus the observed values, right? So in this model, it correctly predicted 393 people voting for Clinton, right? And that was also observed, but it incorrectly predicted 100 people voting for Clinton when they actually voted for Trump. And on the flip side of this, it correctly predicted 254 people voting for Trump and incorrectly predicted 69 people, right? And so that gives us the overall sort of prediction based on our variables. And now, so this is the table we're going to be interested in here. And so I'm just going to make this bigger so we can see it. Can I make this bigger? It does not look like I can. So we'll just leave it like this and hopefully you all can see it. So there's several things we want to look at here. The first thing I always look at is the significance. This is our p-value, right? So if this is less than 0.05, if this value is less than 0.05, we reject the null. Or in other words, we accept the research hypothesis, right? So let's kind of go through these. Trust in institutions is a significant predictor. Think of self as liberal or conservative, right? So you'll see here that we have a null, we have nothing in here, and that's because this first category is the reference category. It's a little confusing because this has a 1, this has a 2. So this first one is going to be the category of liberal. And then the second one is, even though it says 1, is the moderates. And what it's doing is it's comparing the moderates to the liberals. And then it's in this one, it's comparing conservatives to the liberals, right? And so it'll give us a p-value for that, and that's significant, right? So there's a significant relationship between one's political affiliation and whether or not they voted for Trump over Clinton. Age less than 0.05. It's hovering, but it's less than 0.05, so that's significant. How often somebody attended religious services doesn't matter, but family income matters. All right. So let's kind of run down this line here and see what all of these are saying. So trust in institutions is a negative beta coefficient. And so that negative, right, it tells us what the negative tells us is it tells us the direction of the relationship, right? So the significance tells us whether or not there is a relationship. This tells us the direction of the relationship, right? So because it's negative, essentially what this is saying is that people who trust institutions more are less likely to vote for Donald Trump, right? Or the flip side is opposite. People who trust institutions less are more likely to vote for Hillary Clinton. All right. And this one is also interesting, right? So we have significance here. So let's run down this line here. These are both positive. And so what that means is people who are liberal, right, which is this first category here, are less likely to vote for Trump compared to people who are moderate. And people who are conservative are more likely to vote for Trump as well, right? So in this case, moderates and conservatives are much more likely to vote for Trump, significantly more likely to vote for Trump than liberals are. And what's really interesting here is, and then we can go down the line here too, right? So age, older people, because that's positive, older people are more likely to vote for Trump. And people who make more money are more likely to vote for Trump. The really cool thing I think about logistic regression is this exponent B or this exponent beta, exp B, that's our odds ratio. And what that means is it's comparing, particularly for our categorical variable, it's comparing our category, this category here, conservative, compared to our reference category. It's compared to a number of ones. So what this is telling me is that conservatives are 31.7 times more likely to vote for Donald Trump compared to liberals after controlling for everything else, right? And this is telling me that moderates are 5.25% more likely to vote for Trump than liberals are as well. So moderates and conservatives both much more likely to vote for Trump, right, than liberals are. And so that's kind of an interesting thing about this, right, is that exponent B tells us our relative differences there. So the way that I would interpret this is I would say something to the effect of, there are several categories or several factors, several variables that are strong predictors or significant predictors, I would say, of whether or not somebody voted for Donald Trump versus Hillary Clinton. First, we noted that people who trust institutions less are more likely to vote for Trump. People who are conservatives and moderates are more likely to vote for Trump compared to liberals. Older people are more likely to vote for Trump, and people with higher income are more likely to vote for Trump. So that's how I would interpret this data here. All right. So thanks for watching. That's the gist of running a logistic regression, and I hope you all found this interesting.